Hey guys, today I want to go over Coulomb's law. So before I get into Coulomb's law, I want to review some vectors. I just want to review the common uses of vectors in physics. So let's say I have this vector diagram and I'm representing this momentum vector of some object. So I could split this vector up into components, into the x component and into its y component. With this, I can represent this vector as p sub x in the x hat direction plus p sub y in the y hat direction. And if you remember, x hat and y hat are unit vectors. But you probably learned it as I hat and j hat. So these are actually the same as x hat and y hat, and k hat would be in the z hat direction. It's the same thing. As you probably already know, in math and physics, names are really arbitrary. Okay, so how would you find x, or p sub x and p sub y? So let me redraw the diagram. And if I have this angle theta, this kind of just gives it away. If this vector was the length of p, and if I split this up into components, I make a right triangle. So this p sub x component, the length of it would actually be p cosine theta. And this y component right here would be, so p sub y is equal to p sine theta. So with this, I can rewrite this vector as p cosine theta in the x hat direction plus p sine theta in the y hat direction. So that's like a really quick review on vectors, and this is probably what you're going to see in electromagnetism. So now I want to start talking about Coulomb's law. So let me write out the equation. Before I move on, I want to go over what this means first. Q1 and Q2 are the two charges of interest. So let me write that out. Two charges of interest. And don't worry, I'll do an example and I'm sure it'll make all of this more clear. But for now, I'm just going to write out what all of these mean. R is the distance between the two charges. So let me write that out. Now let's talk about this constant. So for now, just know that it's a constant and it's always there. There's nothing more to know. All I could say really is that this epsilon naught has really nothing to do with this section. It's not important at all. Don't worry about it. You'll actually learn more about it in later sections, and it has to do with dielectrics. So now let's talk about the direction of the force. So if I was given this problem, I have two charges, Q1, say it's positive, and Q2, say it's negative. Now this subscript 1 and 2, it just means the force on charge 1 due to charge 2. So if we're talking about the force on charge 1 due to charge 2 would actually point this direction, because these two charges are opposite, so they're going to attract. But to be honest, it's really confusing with this subscript. I find it extremely confusing, and I know a lot of you guys too, because it can really throw you off. And as I said before, numbers and names are arbitrary in physics. This doesn't necessarily have to be charge 1. This doesn't necessarily have to be charge 2. And it could be charge 5 or charge 15. I could even give it a name, charge pen and charge microphone. It really doesn't matter. So what I do, I just totally ignore these subscripts. And I'll actually show you how I solve problems using Coulomb's law. So let me redraw what I have. So if I have the same situation, two charges, Q1, and it's a positive charge, and I have Q2, and it's a negative charge. First, I would establish direction. So if I was interested in the force on charge 1 due to charge 2, I know that this is positive and this is negative, therefore they would attract. So in this case, this charge would go to the right, or the force would point to the right, and if I set up my coordinates as x and y as so, this would be in the positive x hat direction. So I know the force is in the positive x hat direction. So that takes care of direction. Now all I need to worry about is magnitude. And how do you find magnitude? Well, let me just rewrite what I have up top, and I just solve for the rest of the problem. So I would just plug in Q1 and Q2 and my R value. So if R was given, it would just be the distance between these two charges, and I already have direction, so that solves the force on charge 1 due to charge 2.